Hey guys, last video we learned the basics of integration. We learned the basic rules for the power rule and for e to the x and 1 over x. So now we're going to apply these rules to some more advanced examples. So I'm going to start with the power rule and an advanced example of that. First thing I'm going to do is I'm going to pull out the constant. So 4 is going to go on the outside, and then I have 1 over x cubed. Now this is a little deceiving because it kind of looks like we're going to do natural log, but that only works for 1 over x. This is 1 over x to the third. So I'm going to rewrite this instead as x to the negative 3. And so now I can apply the power rule. So the power rule is you add 1 to the exponent, and then divide by the new exponent. So when I simplify that, I have negative 2 x to the negative 2 plus c, or I can move my negative exponent to the bottom, negative 2 over x squared plus c. The next one has roots, which we've never dealt with so far in this unit. So what I'm going to do is rewrite it as a power instead of a root. So remember, the rule is if you've got the nth root of x to some power, we'll call that k, then I can rewrite that as k over n as a fraction. So first I'm going to pull out the constant, and then I'm going to rewrite this as u to the 2/3 du. So now I can find my integral. I've got my 5, and I'm going to add 1 to the exponent. So that I'm going to add 3/3, so that becomes u to the 5/3. And then I'm going to divide by 5/3. Well, the same thing as dividing by 5/3 is multiplying by the reciprocal. So I can write 3/5 times 5 u to the 5/3. Multiplying by the reciprocal is the same thing as dividing by 5/3. And so then what happens is the 5's will cancel out, and I'm left with 3u to the 5/3 plus c as my integral. The next example here, we have 2 things in the top and 1 thing in the bottom, which we haven't dealt with yet. There's no quotient rule of integration. So I'm going to break up this fraction. I'm going to have x cubed over x squared dx minus 3 over x squared dx. You're allowed to break apart the fraction when there's only 1 thing in the denominator like that. And so then I can simplify this a little bit. X to the third over x squared is just x. And then I'm going to pull out the 3 from the second integral and move the x squared to the top so that I can use the power rule. So I'm going to take the integral of each of these separately. I'm going to add 1 to the exponent and divide by the new exponent, and do the same thing in the second fraction. Add 1 to the exponent and divide by my new exponent, plus c. A little bit of simplifying. X squared over 2, the negatives will cancel each other out, so it'll be plus, and then I can move the x to the negative 1 down to the bottom, and then plus c. Number 5, we've got 2 things multiplied together, and there's not a product rule here. So what I'm going to do is I'm going to distribute the x so that I have x to the third plus 2x dx. Well, those are both integrals that we know how to do, so I'm going to split them up. X to the third dx plus 2x dx. Then in the second integral, I can take out a 2 and apply my integral rules. So I'm going to add 1 to the exponent and divide by my new exponent, plus add 1 to the exponent, divide by my new exponent, plus c. And then that simplifies a little bit. We've got x to the 4th over 4 plus x squared plus c. Now I saved the best for last, number 4. This one has lots of square roots and fractions and all that fun stuff. So the first thing I'm going to do is rewrite my square roots and cubed roots as fraction exponents instead. So this will be 2 over x to the 1/3 minus 6x to the 1/2. Then I need that 1/3 to go up to the top. So I'm going to rewrite this as 2x to the negative 1/3 minus 6x to the 1/2. And I'm going to separate the integrals as well. Then I can take the constants out. 2 times the integral of x to the negative 1/3 minus 6 times the integral of x to the 1/2. And now I can apply my power rule. I add 1 to the exponent, so in the first integral I'm going to add 3/3, so 2x to the 2/3 divided by 2/3 or multiply by the reciprocal minus 6x. I'm going to add 2 over 2 because that's the same thing as adding 1. So this will be 3 over 2. And then I multiply by the reciprocal. And now I can just simplify my fractions. In the first one, the 2's will cancel. So I have 3x to the 2/3 minus, this 3 cancels with the 6. So it'll be minus 4x to the 3 over 2 plus c. Pause here and try the practice problems below. Then you can hit play and see how you did. I'm going to give a video explanation of each one. Hopefully you paused where I told you to and gave these a good honest try before just waiting for me to explain them again, because you will have to do problems like these on MathXL all on your own. So for number 1, I need to move this x to the 4th up to the top so that I can apply the power rule. So the first thing I'm going to do is that I've got 2x to the 2/3 minus 3x to the negative 4th dx. Now I'm going to pull the constants out and separate this into 2 separate integrals. So I'll have 2 times the integral of x to the 2/3 dx minus 3 times the integral of x to the negative 4th dx. And now I can apply my power rule. The first integral, I'm going to add 3/3, so that becomes 5/3, and multiply by the reciprocal, because that's the same thing as dividing by 5/3. So I'm going to multiply by 3/5 minus 3 times, now I'm going to apply the power rule where I add 1 to the exponent and divide by my new exponent. So this will be x to the negative 3 divided by my new exponent is negative 3 plus c. And now I can simplify my fractions here. This becomes 6 over 5 x to the 5/3. The 3's will cancel and the negatives cancel each other out. So it'll be plus x to the negative 3rd plus c. The last thing I need to do is move that down to the bottom so it's a positive exponent. So I have 6 over 5 x to the 5/3 plus 1 over x to the 3rd plus c. And that's my final answer for number 1. In number 2, I need to change that from root form to fraction exponent form. And I'm also going to take out the 4 from the integral. So I can rewrite this as w to the 3/5 And then I need to apply my power rule. So I'm going to add 1 to the exponent. So I'm going to add 5 over 5 to the exponent. And that becomes 4w to the 8/5. And I'm going to divide by the new exponent, which is 8/5. But that's the same thing as multiplying by the reciprocal. And now I can simplify this fraction. This 4 cancels with the 8. So I'm left with 5 over 2 w to the 8/5 plus c. In number 3, I need to separate my fractions so I can take these integrals separately. So I'm going to rewrite this one as x to the 4th over x squared minus 8x cubed over x squared dx. I'm going to simplify this a little bit. So it becomes x to the 4th over x squared is x squared. And x to the 3rd over x squared is 8x. And now I can pull out this constant. So I have integral of x squared dx minus 8 times the integral of x dx. And I can apply the power rule. So you add 1 to the exponent, divide by the new exponent, minus 8, and then I'm going to add 1 to the exponent and divide by the new exponent here. So when I simplify this, I have x to the 3rd over 3 minus 4x squared plus c. This last one, I have two things multiplied together. We don't know how to deal with these yet, so I'm going to FOIL it out so that I have separate pieces and I can take the integral of each piece. So I have x squared times x squared times 3, negative 2 times x, and negative 2 times 3. So this becomes x to the 3rd plus 3x squared minus 2x minus 6 dx. And I can break this up into different integrals. So I've got x cubed dx plus, take out the constant, 3 times the integral of x squared dx. Take out the constant again, x dx minus integral of 6 dx. And I can apply my power rule for the first 3 and my constant rule for the last one. So this one's going to be x to the 4th over 4 plus 3x to the 3rd over 3 minus 2x squared over 2 minus 6x plus c. And then I can simplify this. X to the 4th over 4, the 3's cancel, so plus x to the 3rd. The 2's cancel, minus x squared minus 6x plus c. Didn't mean to erase that. And that's your final answer. So don't forget I have office hours 2 times a day, every single day during the week. You can also email me if you have questions, and we can set up a video chat outside of my office hours if you really need to. And I can work through these examples a little slower or do some extra examples with you. You can also screen share your Math Excel questions, and we can go through some of those together. So I hope you understand what's going on here, and please don't hesitate to contact me if you have any questions. Have a good day.